stop at a high point as you go up to what?
4.
4. Look at the y's there. So negative infinity, up to 4, looks like 4 is to be included. So there's your domain of range, just by observing the graph, the x and the y. After that, I said on what intervals is the f of x increasing? Now, a student asked the other day when I was doing one of these, this is along the x-axis. The guy says, I'm moving along the x-axis, I'd like to know from left to right, where do you see that graph rising or increasing? And we'll put it in interval notation. Any guesses? As you go from left to right. I see a hand going up, yes.
From -7 2 until -5 4.
Okay, beautiful. You name the entire point for me. Just name the along the x-axis. What x's from what to what?
-7 to -5.
Okay, there you go. So this is increasing, and he tells the professor, if you want to write like this, -7 over to what was it? -5.
Yeah.
I think we'll put a bracket on that. I think the textbook does put a bracket. I'll give you credit if you put parentheses or brackets. But as you continue from left to right, is there another piece of the graph rising? And describe that for me in, yes, along the x-axis.
From 0?
From 0 over to 4. And if you want to do this, put a comma or a union, it's up to you. And if you want to do this, I'll give you credit. Is the other piece. So those are the pieces, if you look at that graph from left to right, those are the pieces that are rising, increasing. Decreasing, of course, not much left there for the graph. As I go from left to right, now I'm looking for where is it falling from left to right. And guys, it's falling from, and see if you agree with me, along the x-axis, I'm looking at the x's, is it -5 to 0? Is that one piece dropping? Yes or no? Is it -5 to 0? Is that along the x-axis? Yeah. Yep, -5 to 0. Okay, so if you want to do this, and if we put a comma or a union, it's up to you. And another piece that looks like it might be falling, decreasing, would be what?
4 to infinity.
Thank you, 4 through infinity. Make sense? Increasing, decreasing, or did we leave something out? Kyle,
Sorry, I have a related question.
go ahead.
For critical points, should we do inclusive or?
That's exactly what I want to hear. Your textbook, I think your textbook puts brackets, if you guys are trying some of these in the textbook, I think they put brackets on everything, the author of the textbook. And he visited the campus not too long ago. We brought up that issue, why would he do that? But he says either way. Kyle, for example, when you said it's increasing from 0 to 4, try to find that. Guys, right at 4, when you reach that top point there, where it says 4, 2, I think that point's not right, it's just stationary. Isn't it? When you finally reach that top point there, and therefore I, myself, Kyle, you might agree with me, I would do that. So if those critical numbers, I think they're just stationary. Okay, but I don't want you to get caught up with all this, guys. So if I see brackets here, Mr. Park, I'm sure in Math 7, were they more specific with bracket and parenthesis on the increasing, decreasing?
Mm-hmm.
Okay, so we had better, I don't know why in the Math 2 book he allows that. Okay, so guys, make sense here? Kyle, you're talking about this, aren't you?
Yeah.
Yeah. So he says, Professor, maybe at one of those critical numbers you should put a parenthesis, because it's the top number there, it's doing nothing, it's just stationary. It's not increasing or decreasing, it's just stopped. Okay. With that said, increasing, decreasing, we got that out of the way. Now name any local maximum values. Now guys, these are locals. Put it over here. This is a local max. Now I'm looking at it, I think I'm being outrageous. I just need the y values. Please tell me, isn't 4 and 2?
Yeah.
Are those the high points in a particular locality? Okay, so the values would be 4 and 2. If you should name the full point, I'll give you credit. Because they're just looking for the y value for a maximum or a minimum. And next, sure enough, they asked me for, any local, what's that maximum? Yes. Next says name any absolute minimum points. Now I want absolute minimum.
There's none.
And
There's none.
well, in a particular locality, do we have any local mins first? Let's get back to local. I didn't ask for local min.
Zero.
Are there any local mins on this graph?
-3.
I see -3 would be a local. But I'm asking for an absolute, and the absolute says, now, is there a point on this graph that's the lowest of all points?
No.
No? Is that graph dropping down forever?
Yeah.
So is there a particular number I can identify as the lowest? No, it keeps on going down further and further and further, what? Through negative infinity. So there is none. I cannot identify a particular specific number. It drops down forever. There is no absolute min. And on what intervals is f of x greater than 0, guys? Now I'm looking for when is my graph from left to right above the x-axis? And we're going to go along the x-axis there. Guys, along the x-axis, please tell me, it looks like where I'm standing here is -7 to a -3. Is that true? Is that above the x-axis? -7 to a -3. Write mine like this. This is f of x. It's greater than 0. It looks like it's a -7, was it? -7. Let me see how this looks right here. Yeah, -7. Over to a -3. Let me just see the location of a -3. Is -3 right on the axis? Is it right on the x-axis when you reach -3? Am I right on the x-axis? So if it's asking for, is it above the x-axis? No, it's not. Okay, so I would do this. And I think -7, guys, if I look at it closely, was that point at -7, sure enough, above to begin with. So I've seen things going on like this. Now it says, when is my graph above the x-axis? Is it definitely above the x-axis at -7? Definitely above. That's all this means, above. At -3, if you take a close look at the location of -3, I think it's right on the axis. That's why I put a parenthesis there. It's not above. Okay? Is there another interval here where it's above? I'm looking at, guys, help me out here.
2 to 6.
Yeah, 2 out to what, 6? Okay, out to 6, so if you want to put a union here, it's up to you. Now I'm gonna do this first and see if I need to put a bracket on anything. 2 to 6, 2 is right on the axis, 6 is right on the axis, and therefore I'm gonna use parentheses, or not above the axis. Is that making sense? Did we do this okay? Now, so next Wednesday, you'll have a graph drawn for you, and I'll just be asking questions like this. Increasing, decreasing, local max, local min, absolute max, absolute min, domain, range, and all that. Okay? Yeah, go for it.
Yeah, I have just a question about the debate, why it's, I know, I understand why it starts from -7, but why it goes to infinity? Does it just goes to 6?
Beautiful. Does that graph continue after 6? I realize it's dropping down.
It's dropping
But,
down.
whoa, look at this. Got you. I know exactly what you mean. But as it's dropping down, is it also moving over to the right? It's not dropping down on a vertical line, it wouldn't be a function. So is it also gradually moving over to the right as it's dropping down?
I see.
It's moving gradually over to the right forever.
Oh, okay.
What do you think? Do you think it will just drop down like that?
I thought it just.
It wouldn't be a function.
Oh, okay.
Wouldn't pass the vertical line test. That help?
Thank you.
So guys, can we do one of these? Where the graph is actually provided and there's questions answered there? Okay? And I'm not gonna be too strict on, but do try to pay attention to, should I place a bracket, professor, or should I place a parenthesis? Try to pay attention to that for me. On the other side, where the graph is not there, and this is where I think I got into a little bit of on Monday. I gave you a function, let me write this on the board, and it's given to me as, in 3 pieces, f of x equal to, I'm gonna try this black marker here, 2, x is less than -3. Now guys, these can get tricky. And we'll try in red, x squared subtract 7 if this, oh, this is gonna be a nice graph. And the last one, let's try maybe a different color for it. See if this blue will work for me. A negative 2x plus 8. And that says if this is true, x is greater than 3. And guys, make sure I have all that copied down correctly. And you guys were with me on Monday. I've got to graph this, but it's in 3 pieces. I'll use different colors for the pieces here. Black, red, blue. Now, what I like to do myself, and some students may see this without going through what I'm going to do. The first one, f of x is equal to 2. That happens only when x is less than negative 3. Can someone, before I show you what I do, can someone visualize in your mind, what do you think that first piece, the black piece, looks like to show that you're supposed to be at 2 for all x's to the left of, that's the translation, to the left of negative 3. So you're to the left of negative 3, and you're supposed to be at location 2. Describe that for me.
Straight line.
Huh?
Straight line.
A straight line, a complete straight line?
More or less, yeah, no slope. It's just going, it's just staying at y equals 2.
Okay, so you're saying it's a piece of, that's why they call these piecewise, piece of a straight line. Think so, guys? I think its description's perfect. Piece of a straight line. And we'll see here shortly. The one in red should be, since I see a square, should be a parabola, but I don't need all of it. I need just the part of the parabola caught between negative 3 and positive 3. Now, I don't know whether you can visualize right now in your mind what part of that parabola, and by the way, is that parabola, when I finally graph it, opening up or down? Is it opening up?
Opening.
Yeah, opening up, just the way it looks, opening up. But it's caught between what? Negative 3 and
3.
positive 3 only, so just a piece of it. And then the blue one should be a nice piece of a straight line. I see it's in the mx plus b form. And then we'll graph it in blue, and then we have all the graph, and it should be a function. The graph of a function should pass the vertical line test. Guys, what I'm gonna do, you guys who, especially for you guys who may have been out on Monday, you can do this. I don't mind you doing this. You could construct a little table and form a couple ordered pairs to satisfy each one of these pieces. I'm gonna do the black one first. The black one says, well, they gave me negative 3. So I'm gonna start out with, for the x, negative 3. And I go back and replace x, if there is an x, there to see what the partner is, the y value. Well, there is no x. So it stays constant at 2. Also, if you wish to place in that table something less than negative 3, you're allowed to do that also, like negative 4 or negative 5. You guys can put a negative 4 in my table. I know it looks very simple to do it this way, but go back, against constant 2, there is no x to plug in, so it stays 2. And that should be enough, when I get to the grid, enough to graph the black piece. By the way, how many points does it determine, or you must determine to draw a straight line to begin with? How many points do you need? 2, I've got 2. So that should be enough for that first piece. Guys, let's see what that first piece may look like. And I think from his description, I think he described that perfectly. So let's see what it looks like. Label this. And of course, I like my graphs to have x and y there. Now, if I plot a few points, and I've got just a few here, negative 3 up to, I'll just be patient here, negative 3 up to, I want to say it falls right here, negative 3 up 2. Please tell me the way that first black piece is written. May I include that point? In other words, can I darken it in? Because points can be either open or darkened in. Which one should I do? I see a student tell me it should be open. -3 up to, professor, this point should be open. Why?
Because it's like critical point, it's stable, it's not.
Yeah, yeah. Is there an equals mark on this inequality?
No.
No. That says no, you cannot include then -3. Then you include anything else, but you cannot include that initial point. It says everything less than. Now the next point's -1, oh, -4. -4 up to, that's out here. Then I'll get out of your way here. Now that one you can include. It's just that initial point. Now guys, I tried only 2. You can try more points if you wish, but I think students are telling me, connect those 2, professor, you're going to have a piece of a horizontal straight line that looks something like this. And it continues forever in that direction. Do we agree?
Mm-hmm.
Okay, that's the first piece. Now the red one, same thing, I would form a table right quickly. And in the red guys on the X, Y coordinates here, they're telling me I can start out with -3, which I will, and they're telling me to end with 3 in my table. Also, I can try anything in between. I'll try 0. And I'm hoping that'll be enough to get the piece of the parabola. -3, yes, there is a function here for the red one. Replace x by -3, do your math. I think you end up with 2. 9 subtract 7. So that's an ordered pair. Put a 0 into x squared subtract 7, you end up with a -7. Put a 3 in there, I think you end up with a 2. Guys, check my math, make sure I put all that in there correctly. Did I put it in correctly? For those points? I'm trying 3 points here. Okay, now, -3 up to. Well, -3, I used -3 from the black piece. Now I'm in the red piece. It says -3 up to. Please tell me, I'm going to land at the same place where I was on the black piece. And the black piece, though, had it open. Can I now close it in? It says -3 up to. I think it's -3 up to, so I'm back here. At the same point where the black piece was. That's when I'm going to start my red piece. Am I allowed to this time, should I leave it open like it is right now, or am I allowed to close it in? Yeah, I can close it in. Why? That equals mark. So I get to do this on the red. This can now be closed in. Now the other points definitely will be closed in. 0, gosh, what was that? 0 down 7, do this. I'll mark it quickly. Let's say -7 is right there. So 0 down 7 here. Definitely included. And also we got out 3 up 2 looks like to work with. If I do that, I have this. Mark 3 up 2. And guys, by the time I reach the end, that's 3 up 2. Based on what I see, that's my stopping point. Can I include it? Is there an equals mark there? On my ending point? No, so when I get to 3, 2, it's going to be open. Do we agree? Now connect, and it looks like a rough shape of something like this. There's the piece of a parabola for the red piece. Yes?
And you don't extend it upwards because that's the limit, right?
Exactly, exactly. Now the blue piece. Blue piece, I have not created a table yet. You guys can do it right here. And I think every student in class would recognize this is in the MX plus B form, so it's going to be a piece of a straight line. 2 points determine the line, so just 2 points maybe in this table. I am going to start out with 3. They gave me 3. Take it to a function, put it in, that'd be a -6 plus 8, which is going to give me a 2. Place some 3 right here. Anything greater than 3 can be used. We'll try 4. Put a 4 in. Oh, we left out here. Put a 4 in, you get -8 plus 8. I think. 0. I think it's gonna be enough to get the, blue piece. Now, we're supposed to start out with out 3, up 2. Oh my goodness, out 3, up 2. It's back here where I was earlier on the red piece. Do I leave it open this time? On the blue's gonna start at out 3, up 2. That's this initial point. And I notice it's open right now. Am I allowed to now darken it in like I did a previous one? Is there an equals mark on this? No. Okay, so I got to leave it open. So if you want to do this right here, go for it. On the blue. The other point, out 4, 0. Oh my goodness, out here. It's definitely going to be included. And it's here. If I connect those two guys, the piece of the straight line, third piece looks something like this. It looks like it goes on forever. Now stepping back, look at that. Do we agree? Is that true? We got the graph? Go for it.
Isn't the last point supposed to be open?
Which point now?
The blue point on the right? Yeah, but
Right here?
the last one, no one on the right?
Right here?
4, yeah.
Ah, beautiful. Guys, the only point that you're concerned about whether it's going to be open or closed, oh, good question. The only points you're concerned about whether you should open or close are the ones they give you. The others that you create yourself are always closed in. Good questions. This is those points you see on the original function that you're concerned about. Should have placed an open or closed. Mr. Park, looking good? Okay. Now, we got this done. Someone remind me on the handout. Is that all I asked you to do? Just graph it, or did I have some questions? Had to find a few things, right? Like what? Domain?
Domain.
Okay, beautiful. Let's get the domain out of the way. Now, guys, this is on the full graph. The domain. These markers were working well downstairs, but not working now. Domain. That's from left to right along the x-axis. I know, you know, this goes forever this way. So that's like what? Negative infinity. From left to right. Over, goes like that, goes like that, goes like that. Oh, that might throw me off a little bit. I don't know, does it? So how am I going to write the domain, guys? I see one little open spot there that may throw my interval notation off a little bit. What do you guys think?
Could be negative infinity to 3 and then union 3 to
Hang on now. Negative infinity over to
3.
3, and 3 should be open?
Oh, open, yeah.
Okay.
Then union, then open 3 to infinity.
Love it. You guys agree? She's telling me, Professor, you can't let x be 3. You got an open point there. In fact, not a point at all. There is no point there. Okay. Now the range. The up and down. Looks like, if my graph is correct, it looks like -7 is as far down as it drops.
No.
Nope. Does this right here, the blue, say no, 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 it keeps going. So it's negative infinity. I always put parentheses on the infinity and the negative infinity. Now, how high up does it go?
2.
Is that 3 or 2?
2.
2. And negative infinity up to 2. Am I allowed to put a bracket on that 2? Can I do this?
Yeah.
It's just included. It's not included over here, it's included over here though. So it's a negative infinity up to 2 for the range. Is that true? Domain range. Someone quickly tell me, what else did I ask about this? Anything else?
X-intercepts.
What's that?
X-intercept.
Oh, the x-intercept. Oh my goodness, that'll be a gift. And guys, I am going to write these as ordered pairs. There's an x-intercept. Whoa, 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 whoa. I thought it was going to be a gift. I need to know now for the x-intercepts. Oh, I see why now. I may have asked. There's an x-intercept right here. We mark it like this. And there's an x-intercept here. And my graph may not be drawn to scale. And, oh, there's one here. I see 4 for sure, right? Is 4 one of the x-intercepts? It looks like I have 3 altogether. So now these 2 I must name. Oh boy. It is going to be interesting. Now, am I going to stand here and guess? Professor, looks like this x-intercept right here falls between maybe -2 and -3.